I'd really like to thank everyone to show up. This is crazy. This is such a huge audience. Like, it's kind of amazing. We really like to thank Varada and Wix and Demi and everyone else who's sponsored this. This is really awesome. I'm Dane Sundstrom. I'm gonna, there we go. Today, the three of us are gonna talk about just what's been going on recently, what's coming up. So I'm gonna start off by talking about the new Presto Software Foundation. Then Martine's gonna take over and go through a bunch of new stuff we've added recently, and then take a deep dive on one of the new big things that's being worked on in the community. And then David's gonna follow up with like all the things that people are working on around Presto. We launched the new Presto Software Foundation in January 31st of this year. We wanted to create a foundation that allowed us to preserve what we believe made Presto really successful over the first 6 years. From day one when we started Presto, we wanted it to be open source. Like, you can actually go into the Git repo and you can look at the first commit. Like myself and Martine sitting at a desk at Facebook, you can see the first commit. You can see like 6 months after that, we threw all the code away and started over because it was terrible. It was all just really bad. And so, throughout the whole time, we wanted to not only build software that was open to everyone, but like actually build a community around it. I don't have my presenter notes. Well, let's see. So we at Presto have this like vision of building really high quality software throughout the whole process. And one of the things we wanted to do when we set up the foundation was to really go through and capture like how the process works. So throughout the whole thing we had set up, we had pretty much like, the community was small, the number of developers, et cetera, and everything had been, us just talking to other people. When people wanted to get involved, we would just meet up with them and talk to them. You'll still see this on our Slack channel, like anyone shows up and we're just talking and helping them out. But that only goes so far. So one of the really big things we wanted to do was sit down and capture like how things work, what the vision is, what Presto is, what Presto is not. Like, the software has an extremely strong vision that we've laid out in the website, et cetera, and gone through to really help out everyone understand like what we are, where we plan on going with this thing. All right, can't remember if there are any other notes on this. So as part of the foundation, we've set up there's a new GitHub repo, it's Presto SQL. There's a new website. This has like all the documentation about the project, what's going on. Twitter handle is Presto SQL. So you should all go and follow this. When you get the break, go and follow it. We have a Presto Slack channel. So the Slack channel is just amazing. Like, there's tons of ongoing conversations like every day. It's where really all the action happens nowadays. If you're having problems, there's a really active troubleshooting channel. There's developer channels. There's channels that go into deep dives about the timestamp semantics of the language. Like, you can follow pretty much anything in there. On our website, there's a community page that has links to join and follow all this stuff. There's a YouTube channel. We're going to be doing more. So the foundation we set up, we're starting out small, light, lean. It's really set up to just be what the project needs, and we're going to grow it over time. This is where we're starting. There'll be a lot more stuff coming up, we hope. So we launched, as I said, on January 31st. Since the launch, the activity has been like really kind of off the charts. Like, I feel like we tapped into something. Like we set up the foundation to keep doing what we were doing, but when we set it up, then everyone's like, great, I want to be involved even more. So it's like exceeded all of our expectations. So there have been a ton of commits. Like, this is 2.5 months. We have contributions from 50 different individuals. Like, that's really significant across this. We're still maintaining our really aggressive release process. We're hitting about a release every week. We missed one because a bunch of people are on vacation, but yeah, this has been like way exceeded my expectation. I'm super excited, like this conference. This is crazy. Really exciting. We're really happy to see this keep going. So at this point, Martine's going to take over, and I am totally going to take a picture of you all. This is awesome. Everyone actually go wave at the camera. Ah, yeah, perfect. Thank you. Oh, actually, yeah. All right. Here. All right, everyone wave. Oh my gosh, it's crazy. This room is huge.
We'll take another one in the past.
Yeah.
All right. My name is Martin. I'm going to be talking about some of the stuff that has happened over the past couple months. There's way too many stuff to talk like that happened since last year, a couple of years. So we're going to just focus on the things that the project has gained over the couple of months since we created a foundation. So just start with performance. There's a large number of performance improvements. There's if you're using spilling, which is it's a bit of an experimental feature still, you'll notice that we made some improvements that they actually fixed some bugs where if you're running queries that don't run spilling and spilling is enabled, they would suffer from performance problems. So those problems have gone away. We also improved the ability to spill different operators that weren't supported before. So it's a feature that's getting there. So if you want to play around with it, try it out, this would be a good time to start doing it. We've also improved performance of specific query shapes. This is mostly by implementing certain optimizations or optimization rules in the optimizer. They are very specific, so you may or may not benefit from those. However, if you run on AWS and you have Parquet data or org data, you'll see a big benefit from some improvements in the way Presto reads from S3. You should see a reduction in bandwidth and latency, and of course, an improvement in your query performance in that environment. And this is in one of the latest releases. I think it was 303 or 304. And then in the last release, which is 308, came out last week, we made significant improvements to the way the org reader decodes data. And we basically went in and optimized the core loops for decoding each of the data types, made it more friendly for the JIT compiler, Java JIT compiler. And if we benchmark just those loops, we can see speed-ups in the range of 2x to 7, 8x, depending on the data type. So some of them improved significantly. Like, for example, decimal went from about 70 to 80 nanoseconds per value to less than 15 nanoseconds per value decoded. Now, of course, this doesn't mean that your queries are going to speed up by 2 to 7x. This is only one part of the execution. So, and it's only one part of what Presto does when it's running a query. So, you will see some effect, but I don't expect this level of speed up. Now, even with this, we said, okay, let's try to see what's the impact, and we ran the TPCDS benchmarks using these improvements, and we end up with some noticeable improvements. So this is for a set of queries that benefit the most in TPCDS. Looking at the duration, the before and after the changes are applied. And the speed ups in terms of wall time of query duration are in the order of, say, 1 to 15%. This, for the whole benchmark, the benchmark suite accounts for about 9 to 10% reduction in CPU. So that's actually pretty massive. And for individual queries, depending on the query, some of them will benefit more than others. There are some that benefit by or reduce CPU by 1%, and some that reduce CPU by 20%, and the majority are around the 5 to 15% mark. So this is like if you are constrained on CPU, this could be a big win. Hopefully, this applies to org, and we hope at some point we'll be able to port some of these changes to Parquet, so you can also benefit from that. So moving on, we also introduced in the past couple months some language features. Now it's possible to use lateral derived tables, which is a kind of a way to correlated joins in the full context of every join type. It used to be supported only for cross joins. Now you can do it for left, right, full, and inner joins. And we added a syntax for setting comments on tables. So tables can have comments attached today. You can create them with a comment, but there didn't used to be a way to update them. So now it's possible to do it through the syntax. This also comes with an API that connectors can implement, and once you do, you can have your connectors handle those comments. All right, in the connector part of the world, we added a new connector for Elasticsearch. It's still a bit experimental, so there are some bugs here and there, but if you use Elasticsearch, you can start using it. We added support for more data types, for Postgres in particular, and improve org to be able to, the org writer to be able to write files that are compatible with that range of versions from Hive. So if you're using those versions of Hive, you can read data written by Presto. And then there's one significant feature is a new function that allows you to sync your data, the data on S3 or your storage, and create partitions out of that data. So if you have a bunch of files and you want to create partitions, you can use this command to have them register inside the metastore. All right, security, there's a bunch of features around this. There's a couple significant features in the language itself. So now Presto supports full role-based access control, and this comes with syntax for managing roles. You can create roles, drop roles, assign roles to users, as well as a set of APIs that connectors can implement to be able to authenticate authorization based on roles, user roles. And there's a new security model for views, which allows you to, so traditionally in SQL, when you have a view, if you query over that view, the view executes with the permissions of the user that created the view. And that's what the SQL specification dictates. There's a new mode that allows you to run queries, over those views with the permissions of the invoker of the query, of the caller of the view. This allows you to treat views just as a simple way of storing named queries. It can be pretty useful in some scenarios. There's a new set of changes that, so Presto implements the standard SQL authorization model. There are some environments where people want to, especially with connectors, they want to run a query, they want to let the backend systems that Presto talks to do the authorization checks and authentication authorization checks directly. Like for example, if you have a connector for a database, you may have that database configured with a set of users, and you want people talking to Presto to authenticate against that database with their user identity in the database. So now Presto can pass through the credentials from the client all the way to the storage backends, and then delegate that authorization to the backends. And there's an implementation for every one of the JDBC-based connectors, like the MySQL, Postgres, and so on, and for Google Cloud Storage. So if you're running that environment, you can do that. And we've been looking at whether we can do the same thing for AWS S3. Oh, you guys can hear me. All right. All right, the last thing in terms of security is we improved the security for the client protocol. Can you hear me now? Yes? No? No? Now? Okay. All right, so we improved the security of the client protocol, and this is something that allowed users, so some user that wasn't authenticated could potentially access data from a query that they weren't authorized to see. So now that's fixed. All right, so one big project, this is something that we started talking to a bunch of people over the past year or so, and it became pretty clear that for a number of use cases, it was important for Presto to be able to interact more tightly with the connectors and allow the connector to participate in the optimization process. So we started working on this project. We have an approach we're going to talk about, and this is something that will enable Presto to talk and integrate better with more sophisticated backends, especially databases or systems like Druid and Pinot and any system that does something more than just sort data from a file. All right, so Presto for the longest time actually has had a way to involve connectors in optimization. And this was motivated in the beginning by the need to be able to do partition pruning when running queries over Hive. It's very, very common for people running Hive to partition their data, say on date or some other key they use to access the data. And then when they formulate their queries, they put a filter that says, I only want to query data for this particular date. And they may have years worth of data in the warehouse. So Presto, if Presto doesn't pinpoint and target that data directly, queries become very expensive. So we added from the beginning a couple of mechanisms for the engine to be able to push down that knowledge to the connectors when running queries. And the simple mechanism is basically Presto looks at the query filters and extracts some simple information out of them, like that can be represented as a set of range queries, a range of filters over the different columns, and passes that to the connector. The connector can then take advantage of that to say, go and select specific partitions from the Hive metastore, or in the case of JDBC-based connector, formulate a subquery or a query that gets sent to the database. But this is very limited. Like clearly, you can only do so much with this. Like if you have a complex function, you can't push that, and so on. We have another mechanism that allows Presto to, or allows connectors to prune partitions or some data based on more complex filters. And the idea is pretty simple. So if in addition to pushing down those simple filters we just talked about, when let's say you have a table partition on date or a table partition on a couple fields, but you have a complex expression over those fields. What Presto can do is it can push down the connector can ask the engine to evaluate that expression for a given set of values that may be not all complete, like it may be only a subset of all the columns of the table. And then Presto can say, well, when I fill in that expression with those values and I constant fold that expression, it ends up with a result that is either true, false, null, or it ends up with a complex expression. So in the first case, the connector can take advantage of that information to decide, well, if it's false, then clearly any value in that partition will be false. So I can eliminate that partition. And the connector doesn't need to know what that complex expression is. It just needs to know that when it filled in the values for the partition keys, the partition can go away. So let's actually look at a quick example here. Let's say you have a table a filter expression on two columns. And only one of those is a partition key. In this case, A is a partition key. So at during optimization, the connector says, okay, I'm going to try with one partition that has the value Mary associated with A. And it tells the engine, can you evaluate that? The engine says, well, if I apply this function, this is false for that value. So if this is false, the whole expression is false. So it doesn't matter what the value of B is. The expression is false, so the partition can be removed. And if it does the same thing for this value, this is true in this case. So then we need to know what the value of B is before we can say anything about the expression. So in this case, it can't say anything because B might be some other column that's not a partition key, so it can't remove that partition from the execution. So this gives us some better ability to push down and do partition pruning, but it's still not sufficient. What we want is, and this is based on everyone we talked to, they had some set of requirements around being able to push down projections, being able to select fields from different structural types, from maps, from arrays, and so on. Or even being able to push down aggregations or even joins. And we threw in like limit and sampling for good measure. It was actually easy to consider, so we just decided we're going to try to do it. So we're trying to solve this problem now. And there are a number of different ways we can approach this. We basically took the pragmatic approach. We said, let's do something that can be implemented incrementally, so we don't need to get the whole thing done before anyone can start getting value out of it, and something that we can do over like in the period of a couple of months, like something that doesn't take a long time. We don't need to re-architect the whole system to do. And we're going to cover this. Before we get into that, let me briefly go over how the optimizer in Presto works. So the optimizer works by there's a collection of transformation rules. So the plan in Presto is basically a tree, like tree of operations. So it could be a join, that could be a predicate, a projection, a filter, a table scan, and so on. So the optimizer, what it does is it looks at a set of transformation rules and tries to apply them repeatedly on that plan until nothing else changes. You could think of that as so those rules have a pattern of that they need to match of the tree, and then some logic to apply a transformation. And you can think of that as it's analogous to doing a regular expression substitution on the tree. So you match some pattern and then you substitute, except that it's a lot more complex. It can be a lot more complex. The substitution is it can invoke arbitrary code. It can talk to arbitrary systems. It can have custom logic and so on. So for example, some of the rules are aware of the cost of different operations, so they can decide whether to apply or not, or they can tweak their transformation based on that. So in this case, we can see there's one rule that matches a pattern of B over a C with any two children and transforms it into something that has the B below the right hand of the C and then the original children. And when the rule applies, first matches on this structure of the tree, then it applies, and it transforms just those three nodes in this area. And the process continues. There might be another rule that matches a B over an E, and when it gets applied, it gets transformed into something like that. And the process repeats, like until at some point no more rules can be applied, or there's no way to continue to change the query tree, and then optimization is considered done. So we're taking advantage of this approach, of this piece of infrastructure to implement the ability to push down different operations into connectors. So let's look at how that works. So let's consider that query. We have it's a simple aggregation query that filters by, it has some complex filter. So the table has two columns. One is a row type. Let's say we have a connector that has that data decomposed. So instead of keeping the row structure as one blob, it has the two columns separate, the two fields F and G separate from each other. So we would benefit from you being able to target just one field, so we can read less data from storage. And then let's say there's a complex expressions like y, like, and some pattern. So the plan might look like something like this. There's a scan and the filter applied on top. There's a rule that called tentatively filter into scan, which is basically push a filter into the table scan that matches the specific pattern. So the rule looks at these two operations. It extracts the reference to the table. It extracts the filter. And then it invokes a new API. This is an API that we're implementing that every connect or any connector that wants to participate can implement, that Presto will invoke to pass that information. Then the connector can decide, I support that, I don't support that, I support part of the filter but not other parts, and then returns a result that says, I understood some part of the filter. In this case, let's say the connector understands how to do x.f. And then let's say it understands how to do a like expression because it has, I know, a full text search index or something like that. So it responds with, here's a new version of that table. You can think of it logically as a derived table that internally has enough information for the connector to know that it has to, at runtime when the query executes, it has to apply those filters that it understood. But let's say it doesn't know how to execute the comparison with 5. So what it can return is it's something that says, look, this is a new filter, a filter I couldn't understand, so you need to evaluate, you being the engine. So evaluate that before, after the data is produced, and because it understood x.f as something you can do natively, it says, well, I'm going to return you just the value for x.f, but it returns it as a new synthetic column that it calls z in this case. So the rule then takes that information and replaces those two nodes with a new scan over that derived table and the new filter. So it's pretty straightforward. So I actually lied a little bit here because this is not just predicate pushdown, it's actually doing a projection pushdown. x.f is a projection embedded in that filter. So the idea is we can do the same trick for every one of the operations that we want to be able to push down into the connectors. We can do the same thing for apply limit, which, by the way, is already implemented. So a connector can implement that function. I can benefit from that. We can do the same thing for aggregations, for joins, etc. And that's the approach we're taking. So supporting each of these features is a matter of adding a new API and a new rule that matches the pattern, applies the transformation, invokes the function, applies the transformation, and replaces that with a different set of nodes. And these are some of the APIs we're considering. This one's already done. We're working on that one. And then these are going to come after. And the nice thing about this is that it allows us to do it incrementally. So if, we start hearing from people that, being able to do, join a push down because they talk to MySQL databases and they want to be able to push the entire joins between two MySQL tables into the MySQL database, then it's easy. We add a new version of this API for that operation. We add a new rule, and it's just a localized change. We don't need to go and change the entire system, entire framework for doing that. And then depending on requirements, we can add more and more and more over time. So if we put everything together, we can look at this query. So simple group by with a filter. The plan might look like something like this. There's a table scan with a filter that says some projection. There's no projection there, but let's say there is one. And then the aggregation. So the engine considers all the rules, and it says, I can match the push filter into scan rule can match this pattern. It calls the connector, does all this work, and then replaces that with a new table scan. And let's say the connector understands the entire filter, so there's no need to add a filter on top. So now there's this point to consider. And the optimizer keeps looking at rules. It matches a projection over a table scan, and then applies that specific rule. And then now we have an aggregation on top of a table scan. And you can notice these are different versions of the table. Like these are, you can think of an identifier of a derived table that the connector understands. This one is just the raw data. This one is the raw data plus a filter. This is the raw data plus a filter and a projection. And then it considers these two operations. They match the push aggregate. It pushes the aggregation. It gets replaced with a single table scan. So at the end, you end up with one plan, a plan that contains just one node that appears to be a table scan, but under the covers is a full query that can execute against a remote system. Like it could be a database. It could be something like Druid and so on. All right, and with that, Dave is going to continue talking about some of the other projects that are going on, and they're going to happen over the next few months.
Thanks. Hi, I'm David. We're going to talk about things that are coming up. So the Presto roadmap is it's dynamic. It changes based on what people actually need. The majority of people working on Presto are working on it at a company, so they're adding features or improvements that are based on their business needs. And for the Presto project, when we talk about roadmap, we're not talking about what a lot of people think of as a wish list. Like we have hundreds of things that we would like to add to Presto, but that's not the roadmap. The roadmap are things that people are actively working on right now or that have committed to work on in the near future. So these are things that we have high confidence that will actually land soon. On the Presto SQL on our issues, there was a roadmap label, and so we've tagged all of the issues that are identifying roadmap items that people are working on. And if you go to those issues, they typically have like one or more pull requests or like other like sub-issues that compose that item, because some of these things are pretty big. Like one of the roadmap items is fixing timestamps, and that's got a whole bunch of different dependencies. All right, so we've got a number of things that we're working on in the core Presto engine. The first one is fixing identifiers. So in SQL, you've got two different kinds of identifiers. You've got normal, when you just type a name like ABC, that's case insensitive. It doesn't matter if you type it in upper or lowercase. But you can also quote it with double quotes, and that identifier will then be case sensitive. So if it's all lowercase or if it's all uppercase or mixed case, typically like the database will preserve the case of it, and it only matches if it's exactly the right case. When we first implemented Presto, we only went with case insensitive identifiers because it was, thanks. We only implemented case insensitive identifiers because that's all we needed, and we figured this is going to be easy to fix later, and so we'll just punt on it, because when you're working on a new system, like there's a whole lot of things you can do, so you've got to like pick and choose. This turned out to be a mistake because it was really hard to fix later. So lesson learned there. Some things are easier to fix later than others. But we've got somebody working on fixing that, so that'll be great. Because a lot of backend systems like other SQL databases actually are case sensitive, so it's been important. Whereas like things like Hive are case insensitive, so it was never an issue in the past. Timestamp is another thing that we got wrong, and it was really expensive to fix. Timestamps in Presto, we treated them as an instant rather than a wall clock time, and that's been like pervasive across the entire engine and across all the connectors that Presto talks to. So there's been a multi-year project to actually implement that correctly and then fix it in a way that is backwards compatible to everybody's existing queries and existing connectors. And so we're pretty close to having that having that done. There's actually a page in the documentation that explains the old and new semantics that you can check. There's like a session property that also lets you flip between the old and new behavior. And there's also there's a channel on Slack that you can join if you're interested in learning about the work or have any questions about that. Dynamic filtering is another feature that was started a couple years ago. It was originally worked on by Teradata, and then Qball picked up that work, and it's pretty close to going in. Dynamic filtering is a way that lets you basically do partition pruning or other types of pruning at runtime. Like if you're doing a join between two things, you can figure out what are the values on one side and then move them to the other side, and it can have huge performance increases for queries. So that'll be exciting when we land that. And there's a whole bunch of different variants of that. We're landing one, and it's going to include some infrastructure that will allow us to do more versions of that in the future. We've talked to a lot of people about functions, and there's a couple of different needs that people have. One is, so today in Presto, functions are either they come from the engine or they come from a plugin. And the functions are loaded at startup. They can't be changed once the server is running. And we're adding a thing so that plugins can provide functions dynamically at the time of a query. It'll actually be resolved transactionally based on the current transaction. So it'll allow you, like maybe you're at a company and you've got some repository of functions and you want to be able to like load and modify them dynamically. This will allow plugins to do that.
Like UDFs.
Yes, yeah. This basically allows you to have like UDFs like in like Hive or other systems and like load them dynamically. And the other thing is that end users want to be able to easily create functions. And so we're going to have like basically create function in SQL, and you'll be able to write functions. And we're going to first target the SQL procedural language that's defined in the SQL specification. So you just use like the SQL language to write basic functions and loops and stuff like that. And that's going to open the door for other languages, like in the future somebody might want to add like JavaScript or Ruby or whatever. All right, we've got a lot of connectors coming up. People are working on like Phoenix and Iceberg and Druid and Kinesis and others. And these are all done by different people in the community. Like Phoenix is being worked on, somebody who actually works on the Phoenix project. You got people from Qball and Uber and Netflix, yeah, that are working on connectors. I know I'm speaker notes, so I don't remember that. So we're excited about all these different connectors because one of the strengths of Presto is being able to talk to all these different systems. We've got Ranger integration. Ranger is an Apache project that does authorization. It's actually a couple of different parts. One part is Ranger for Hive, which will allow you to authenticate or authorize Hive tables and column level security against Ranger. And Ranger also is it could do system-wide stuff as well. So you could actually use Ranger to provide security across all connectors in Presto. So like you might be able to do column level security for MySQL using where that authorization information is stored in Ranger. So that's pretty exciting because a lot of people have been asking about that. And then finally, Z-standard support in ORC. Z-standard is a new state-of-the-art compression method. It gives you the same compression as zlib or gzip, but it's several times faster. So there's actually like no reason that you wouldn't use it. So when that lands, it'll be a huge performance improvement for queries that are using ORC or other file formats that support it. And then working on a number of things like the infrastructure to actually run Presto in your environment. Coordinator high availability is something that people ask us about a lot. Today, you can only have a single coordinator for your Presto cluster. We're going to be able to have multiple coordinators in the same cluster. For people that are running things like Hive workload, you typically don't run a lot of queries. You can even have like a cluster with 1,000 machines, and a single coordinator is more than enough to handle that load. Like the coordinator isn't doing a whole lot. People in other environments are running queries that run like in under a second, and they're doing very high volume, so the coordinator can actually become a scalability bottleneck because it's doing a lot of work. It runs out of CPU, so having multiple coordinators is important there. And then another one that we often get asked about is spot instances. Spot instances, like we were looking the other day, and they're actually like 75% cheaper. So we're like, oh, of course everybody's asking about this. Like, it's a much cheaper way to run your clusters. And there are going to be a number of improvements going into Presto that will allow it to work better to scale up and down spot instances. And then a lot of people want to run Presto with Kubernetes. There's a channel about that on Slack. And we're going to work a lot to make Presto work better in those kind of cloud environments. The work on spot instances and Kubernetes kind of all tie together. Like, there's just a whole lot. Because at Facebook, when we wrote Presto, Facebook only had full data centers where you'd get a room, you'd fill it up with a bunch of machines, and like that was it. You didn't really expand. So, or you would only expand. You never had to like scale up and down dynamically because we had, here's your machines to run Presto, and that was it. Whereas in cloud environments, you've got all the elasticity of the cloud. So that's going to be important. All right, if you want to get involved, we've got our Slack. And getting involved in Presto is not just writing code or writing features. Filing issues is a great way to get involved. It's reporting bugs, telling us what works, telling us what doesn't work, improving the documentation, telling us what you found in the documentation that wasn't helpful. So yeah, and just like telling us how you're using Presto is helpful. Oops. Thank you.